Unit 3 transformations, lesson 3.3 is rotations. Rotations. Triangle A in that first diagram off to the left has been rotated clockwise 90 degrees, 180 degrees, 270 degrees about the origin to form those triangles, and now it's right back where it started. We can also do counterclockwise rotations. A rotation takes a figure and turns it around a point, center of rotation. We're going to be using origin, and in these two examples, it's also, the origin. So A, look at triangle A. Went 90 degrees counterclockwise. Now it's gone 180, 270, and 360 to get back where it's rotations about the origin. A turn. This is what rotation is. A turn around a fixed point called the center of rotation. The figure rotates at a specific angle and direction. Could go clockwise, could go counterclockwise. Though the figure can rotate around any fixed point, the most common center of rotation is the origin, which is right there, the point 0, 0, and that's the only one we're going to be using. Counterclockwise. Here's some rules for 90 degrees, 180 degrees, and 270 degrees. And all of these are based on counterclockwise, except for 180 because it's the same either way. 90 degrees counterclockwise is going in that direction. It takes any point xy to the point negative yx. So all the original y's go in front and you do the opposite sign. And then you move all the x's into the second spot in your point. 180 goes around two quadrants, so it's like two 90-degree turns. And it could go in either direction, counterclockwise or clockwise. You get to the same spot. So any point xy goes to the point negative x, negative y, which does not mean the values are negative. It means it's the opposite sign of what it was originally. So if it was originally positive, it does become negative. If it's originally negative, it's going to become positive. All right, 270 degrees counterclockwise all the way around to there. Here we go. Takes any point xy to the point y, negative x. So it takes all your y values and puts them in the front slot in the new x position. And it takes all your x's, switches the sign, because we want the opposite of x in the y position of our image points. Figure ABC was rotated 90 degrees clockwise about the origin. We have points, I gave you those. A is at 1, 1, B is at 2, 4, and C is at 5, 1. Let's put down the coordinates. A prime looks like it's at 1, negative 1. B prime is at 4, negative 2, and C prime is at 1, negative 5. Okay, so this is clockwise. This isn't one of the patterns or rules that we had on that last slide, but let's see what's going on here. All right. Ooh, figure ABC was then rotated 270 counterclockwise about the origin. And it ends up in the same locations. So takes any point, either 90 degrees clockwise or 270 degrees counterclockwise, takes any point x, y, and changes it to y negative x, or the opposite of x. It's not always going to be a negative number. All right, 270 clockwise. It's in the diagram. It starts with the exact same figure. A is at 1, 1, B is at 2, 4, and C is at the point 1, 5. Excuse me, 5, 1. Let's give the coordinates. A prime is at negative 1, 1. B prime's at negative 4, 2. C prime is at negative 1, 5. Look at what happened to your x's and y's. Did they change locations? Did they change signs? Figure ABC was rotated 90 degrees counterclockwise. Ends up in the same spot. Negative 1, 1, negative 4, 2, and negative 1, 5. So same spot, different transformation, but same ending point. It takes any point x, y, and it rotates it to the point negative y, or opposite of the original y first, and then x. Rotations in the coordinate plane, example 1. We are to graph and label each figure and its image under the given rotation. About the origin, triangle ABC has vertices A at 2, 7, B at 6, 5, and C at 4, negative 1. We're doing a 90 degrees counterclockwise turn. There's our rule. Let's plot our points. A is at 2, 7. B is at the point 6, 5. C is at the point 4, 1. Now let's look at our rule. We take our y's and we move them in front and change the signs. We take our x's in the original pre-image and they become the y's in our image. And then we plot our points. A prime's at negative 7, 2, B prime's at negative 5, 6, and C prime's at negative 1, 4. Example 2, same directions. This time we have a square, P, Q, R, S, with vertices. P's at the point 2, 6, Q's at the point 6, 5, R's at the point 5, 1, and S is at the point 1, 2. 180 degree turn rotation about the origin. It doesn't matter if it's rotated clockwise or counterclockwise. We get the same thing. Here's our rule. Let's do P, Q, R, S. Let's plot those and connect our points. And let's look at our pattern. We take our x's from our pre-image and they go in the x spot but change signs. We take our y's from our pre-image. It goes in the y spot and we change their signs. So P prime's at the point negative 2, negative 6. Q prime's at negative 6, negative 5. R prime's at negative 5, negative 1. And S prime is at the point negative 1, negative 2. And there is our image under a 180 degree rotation of our original square, PQRS. All right, rotations in the coordinate plane. Example 3, trapezoid JKLM has vertices J at the point 3, 4, K is at the point 6, 4, L is at the point 8, 1, and M is at the point 1, 1. We're doing a 270 degree counterclockwise turn. Here is our rule. Let's plot our points. J is at the point 3, 4, K is at 6, 4, L is at 8, 1, and M is at 1, 1. There's our original trapezoid, our pre-image. Now let's see, look at our rule. We take our Y's from our original, put them in the X spot, and they don't change signs. Put our original X's in the Y spot, but they have to be the opposite signs of what they originally were. Let's plot those points. J prime is 4, negative 3. K prime is at 4, negative 6. L prime is at 1, negative 8. And M prime is at 1, negative 1. There is our image after a 270 degrees counterclockwise rotation about the origin. Here are all of our patterns. They should be posted and you should have them organized on a piece of paper so it's easy access.